Well, good morning, everybody, or maybe I should say good afternoon. Anyway, welcome. This is a regular meeting of the Standing Senate Committee on Energy, the Environment, and Natural Resources. We continue our study into the energy sector and the view to developing a strategic framework for a future more sustainable energy system, more efficient and cleaner and greener in this country. We've been at this for almost 3 years now, and the committee has just finished 2 weeks of traveling in the western part of the country, continuing its dialogue with Canadians on these matters of energy, actually, and the environment and the economy, all three of which are so inextricably intertwined. And we are back here with our heads spinning with all kinds of wonderful new data, information, and things that we learned in British Columbia, Alberta, Saskatchewan, and Manitoba in the last 2 weeks. This morning, colleagues, we're going to have a slightly different perspective on the climate change issue. As you know, we've all heard many things about climate change and as it does relate to and affect the production of and the use of energy. We've heard many people saying that we need a price on carbon. We've had some lonely voices in the West saying maybe we shouldn't have a price on carbon. And this morning we've invited these 4 distinguished professors who have expertise in climate and in geology and paleontology. I hope you all have their bios. I read them all last night, and you're all very distinguished gentlemen. So rather than read them all, I'm going to trust that my colleagues have had a look at them. And perhaps when you're in the middle of your discussions or at the beginning, you might want to just elaborate on your backgrounds. We senators, of course, never know whether we get home for Christmas or we stay here to bring the coal over to Mr. Justin Trudeau or any of his colleagues, but what we're going to do is try to keep the 4 witnesses to 10 minutes each and then have questions. And I'm hoping that we'll have 15 minutes at the end, colleagues, for an in-camera session about our trip and about the way forward. So without further ado, I'm Senator David Angus. I'm from the province of Quebec. I chair the committee. To my right is Senator Grant Mitchell, and he's from Alberta, and he's the deputy chair. And to his right is Marc Leblanc and Sam Banks from the Parliamentary Library. And to Sam's right is Senator Richard Neufeld from British Columbia. A guest here with us today, a man that's been hovering on the edges of our committee, a great guru from the northern part of Canada, Senator Dennis Patterson. Welcome, Dennis. Nice to have you with us this morning.
Thank you.
And Senator Bert Brown from Alberta. Bert is Canada's only elected senator at the present time. To my left is our clerk, Lynn Gordon, who you've met, I think, gentlemen. My predecessor, Senator Tommy Banks from Alberta, Senator Rob Peterson from Saskatchewan, the pit bull from Whitehorse from the Yukon Territory, Senator Dan Lang, who's well known to the committee, but also a guest this morning and a very welcome one. And to his left is Canada's female athlete of the 20th century, Nancy Greene, Senator Nancy Greene from British Columbia. So Nancy had a bit of a hand in the program this morning, colleagues. She's been following our deliberations and our issues with great interest and debating with me into the wee hours of the morning on issues. And I think she made the point that it's good to hear both sides of the story. So that's what we're going to do. And last but not least, from New Brunswick, Senator John Wallace. Good morning, John. Good morning. So that's it. I believe you gentlemen are going to proceed one after the other. And was it you, Professor? Who's going first? That's right. Okay, so, Professor McKitrick. Over to you, sir.
Okay, good morning. My name is Ross McKitrick. I'm a full professor of economics at the University of Guelph, where I specialize in environmental economics. I've published on both the economics of climate change and statistical analysis and climatology. I was an expert reviewer for the Intergovernmental Panel on Climate Change, 4th Assessment Report, and in 2006 I was one of 12 experts from around the world asked to brief a panel of the U.S. National Academy of Sciences examining paleoclimate reconstruction methodology. The global warming issue is often described with emphatic claims that the science is settled, the situation is urgent, and the necessary actions are obvious. The reality is that there are deep disagreements about underlying scientific issues. There is reason to believe the problem has been exaggerated, and most policy proposals simply do not pass objective cost-benefit tests. Amidst the disputes and controversies of the past few years, I believe 2 points have emerged with clarity. First, the economics of climate change do not favor Kyoto-type commitments. Under current and foreseeable technologies, the greenhouse gas policies that we can afford to undertake would have such small climatic impacts as to be pointless. The same kinds of models that are used to forecast global warming predict that if all the signatories to the Kyoto Protocol complied with their commitments, the level of carbon dioxide in the atmosphere that we would have observed by 2100 would instead have been reached by about 2105, a trivial difference. And Kyoto was too costly for countries to reach. When a policy is proposed that is too costly to implement and yields benefits that are too small to measure, you would expect reasonable people to see it as a bad idea. Instead, we observed a dogmatic elite consensus in support of Kyoto. In my mind, this never validated Kyoto. It merely discredited the elite consensus and suggested to me that the international political milieu in charge of the climate issue was unduly susceptible to groupthink. Unlike such air pollutants as sulfur dioxide and particulates, which Canada has been very successful in reducing, CO2 is not easy to capture, and once captured, there is no obvious way to dispose of it. There appears to be no way to cut CO2 emissions on a large scale without cutting energy consumption and impeding economic activity. Despite their enthusiasm for embracing targets, policymakers around the world have not been able to cut CO2 emissions while pursuing economic growth. Simply put, with regard to most climate policy, the cure is worse than the disease. Second, the official process for assessing technical and scientific information on climate change for the purpose of advising policymakers has become untrustworthy due to bias and partisanship. As a member of the expert review team for the last IPCC report, I saw things take place that violated long-standing principles of peer review. I documented some of them in various publications since 2007, but the issues never received much attention until the fall of 2009, when thousands of emails from top IPCC scientists were leaked onto the Internet. The so-called ClimateGate emails confirmed the reality of bias and cronyism in the IPCC process. The new leaks last month, you may not know, but another 5,000 emails were leaked back in November, provided even more confirmation that climate scientists privately express greater doubts and disagreement about climate science among themselves than is reflected in IPCC reports. Earlier this year, I was asked by the London-based Global Warming Policy Foundation to review IPCC procedures and to make recommendations for reform. My report was published last month and includes a foreword written by John Howard, the former Prime Minister of Australia. I have included a copy with my submission. I mainly focus on how the IPCC handled issues with which I have first-hand knowledge as a contributor to the peer-reviewed literature on the subject, and on which I worked closely on the IPCC text in my capacity as an expert reviewer. The IPCC is not a neutral observer of the scientific process. Instead, it has a party line. It is controlled by a relatively small bureau in Geneva, consisting of a small core surrounded by a network of supportive academics and government officials. The oversight body, called the IPCC Plenary Panel, is passive, inattentive, and overly deferential to the Bureau. In effect, there is no oversight. The Bureau picks lead authors who share their views. They are routinely placed in the position of reviewing their own work and that of their critics, and are free to rule in their own favor. Lead authors are also free to reject reviewer comments, override review editors, and even rewrite text after the close of the peer review process. The combination of Bureau control over the selection of lead authors and a toothless peer review process means that IPCC assessments are guaranteed merely to repeat and reinforce a set of foregone conclusions that make up the party line. In my report, I document some disturbing cases where the IPCC violated proper peer review practices. These include manipulating prominent graphs so as to conceal known flaws in the statistical basis of paleoclimate reconstructions and to exaggerate evidence that modern climate change is historically exceptional. This is the so-called hide the decline scandal. Fabricating a statistical test result to provide a rationale for dismissing published evidence of urbanization-related contamination of the surface temperature record on which key IPCC conclusions were based. Waiting until the close of peer review, then removing text that had initially and correctly cautioned readers that the IPCC method of calculating warming trends likely exaggerated their significance, and replacing it with unsupported text saying the opposite. My report documents these and other incidents that, in my view, suffice to discredit its claims to rigor and objectivity and point to the need for procedural reform. In 2010, the Inter-Academy Council reviewed IPCC procedures and drew attention to many of the same problems as my report does. Unfortunately, the IPCC's internal reform process has gone nowhere. I discuss this problem in Section 4 of my report. At this point, we could simply muddle along for another 20 years, enacting more and more costly and wasteful schemes based on the increasingly biased and unreliable guidance of the international climate policy milieu. That would be the easiest course of action, but it would not serve the public interest. The more difficult option would be to begin the hard work of improving the decision-making process itself, beginning with reform of the IPCC. My published research has led me to believe that the IPCC has overstated the global warming issue. I have shown that the spatial pattern of warming trends in the surface temperature record is strongly correlated with the spatial pattern of industrialization, even though this pattern is not predicted by climate models as a response to greenhouse gases. This indicates that the standard climate data sets likely have a warm bias due to their failure to correct for disturbances of the land surface from urbanization, agriculture, and so forth. I've also shown that climate models predict significantly more warming over the past 30 years in the tropical troposphere than is observed in satellite or weather balloon records. This is a key region for measuring the water vapor feedbacks that control the magnitude of greenhouse warming. Despite this being the region that models say should be warming fastest in response to greenhouse gases, the 50-year balloon record actually shows no positive trend once the effect of ocean circulation changes in the late 1970s are removed from the record. One of the most telling emails in the so-called ClimateGate 2 archive that was released last month involves one IPCC expert warning another that their efforts to finesse this issue by deceptive trend analysis is, quote, a fool's paradise. Today, you have a chance to hear from a number of serious Canadian scientists about work that they and their colleagues have done that also calls into question aspects of the IPCC party line. The fact that you have learned little of what they are about to tell you does not indicate any deficiencies in the research they or their colleagues have done. Instead, it points to deficiencies in the process that was supposed to have brought this information to your attention long before now. Thank you.
Thank you for your candor and very well presented, how shall I say it, outline of the issues without pulling any punches. I just wanted to ask you before I go to the next presenter, you keep talking about these leaks, and we keep reading about these leaks. You know, it's an easy thing. I chair a big hospital board, and every morning in Montreal I'm reading in the paper stuff that happened in my board meetings, and they say, oh, well, it's a leak. And, you know, who are these leakers? I mean, do you have any idea? Because, you know...
In fall of 2009, I was interviewed by the UK police because I was living in the UK at the time. My conjecture at the time was it was an accidental disclosure by the university of an archive that had been prepared in response to a Freedom of Information request. However, there has emerged an individual in the UK who's anonymous who has engineered the second leak and has also released an archive of what looks like at least another 20,000 emails, but it's encrypted, and has indicated that he's not prepared to release the decryption code. So it appears to be a single individual with access to a server at the University of East Anglia. The emails cover a span from the late 1990s up to the fall of 2009. And the person clearly understands the issues because he or she has selected according to specific themes that are relevant to climate research. So just yesterday, the UK police raided a few bloggers and also issued retention orders to some American internet providers. They're trying to find out who the person is.
Well, you know, we're trained to be cynical here, and when people like to remain anonymous, the credibility is in question. But I just wanted to make that point, because over in the UK, waiting to be extradited to Sweden is a well-known international leaker. I think his name is Assange. Or
Julian Assange. Well, in this case, the emails aren't anonymous. They are, and they have been validated by the people involved, that these were actually the emails.
The real things. And they're all from that same source at East Anglia University?
Yes.
Next presenter is Professor Ian D. Clark, Department of Earth Scientists at the University of Ottawa. Professor Clark.
Thank you, Senator Angus. Good morning, Senators. And I want to thank you very much for giving us this opportunity to talk about the science behind global warming. My name is Ian Clark. I'm a professor, as I say, at the University of Ottawa of Earth Sciences. This is the first time that I've tried to teach my paleoclimate course in 10 minutes, but I'll give it my best shot. What I want to present, today is global temperature and CO2, the geological record. So we'll go back through time, and we'll start with the last 150 years. And this period of time is characterized by a cold spell that we refer to as the Little Ice Age, and it ended about 1900. And this was a period when glaciers advanced globally. Agriculture failures were common. The Greenland colonies failed. But it ended about 1900, and that started what we call the 20th century warming trend. And so we've had about 100 years of warming, and the characteristics of this warming trend are, it's rather bimodal, where we had warming up to the 1940s, cooling again through the 50s, 60s to the mid-70s, and then a second warming trend through the 80s and 90s. If we look at CO2 during that time, CO2 was a steady baseline at about 280 ppm in the atmosphere. And during this warming trend, CO2 rose up to about 380 ppm. Today, the warming trend that we're concerned with is really just this last bit, because CO2 in the earlier part of the 20th century was really too minor, and the IPCC and most scientists agree that this was all a natural warming trend here, and that this is potentially the anthropogenic trend. Here's the global CO2 anomaly, and to put it into perspective, we're looking at about a 35% increase in CO2 derived from ice cores and then dovetailed with actual air measurements, which were started in the 50s in Hawaii. If we look at the past 50 years, 55 years, we see that through the 70s, temperatures were quite low during that cold spell, and then they start to rise through the 80s and 90s up towards the last decade. But examining the last decade shows that temperatures really have flattened, and so we haven't really seen any global warming for about the past 10 years, some say since the 1998 El Nino. And this is in stark contrast with the IPCC forecast of an increase of some 0.2 degrees per decade that should have occurred during this period. So this is quite controversial, what's going on at that time. Is this 20th century warming unusual? Well, we go back to 1,000 years before present, and we see a warm period, which we call the medieval warm period, which occurred centered on 1,000 years ago, lasted about 200 years, well documented by agricultural records. The Vikings settled in Greenland and came to Canada. So there's lots of documentation and proxy records for the medieval warm period, followed by the Little Ice Age and then 20th century warming. But during that period, we didn't see any effect of CO2. So CO2 was flat during this time, And so there's no correlation with this greenhouse gas. We go back further in time, here over the last 10,000 years, and this is the Holocene interglacial following the past glacial period when glaciers covered Canada. And we see that here the 20th century warming is one of a series of climate optima. There's the medieval warming period, the Roman climate optimum during the time of Christ, and then we go back further in the Holocene and we see various optima, warm periods of varying intensity and duration. So the current 20th century climate warming is really one of a series. There's nothing unusual. Furthermore, throughout this period, CO2 was a relatively steady 280 ppm. So CO2 had nothing to do with these warming periods. We'll go back further in time, here looking at the record from ice cores in Antarctica, and these are very robust records of climate. And I'm reading from present day back 450,000 years. The records now go back closer to 1 million years, documenting interglacial periods. And here's our current, the Holocene interglacial. There's the last glacial period when glaciers covered Canada and many parts of Europe. And then our last interglacial, we have these series. Clearly, climate has been changing quite dramatically over this time period. And when we look at CO2, we see a very strong correlation. CO2 is increased during the interglacials, decreases during the glacial maximum period down to 180 ppm, back up into this last interglacial, again up to 280 to 300 ppm. So CO2 is strongly correlated with climate, apparently. Well, we have to look more closely at this correlation, and this is where the science becomes obfuscated, particularly by Al Gore and other people promoting CO2 as a forcing agent. And here we're looking at a very detailed interface between a glacial period here at 245 to 240 and an interglacial period. So we have warming shown in red, and that warming occurs about 800 years prior to the CO2 increase. So CO2 is lagging temperature increase by about 800 years. And this has been demonstrated for all these glacial, interglacial interfaces through time. So we're always seeing a lag. CO2 is not driving climate. CO2 is not acting as a greenhouse gas over this very important period of strong climate change. Now we're going to go back over the last 500 million years of Earth history. This, I'm presenting research by Jan Veizer, my colleague here, and this record shows a decoupling of CO2 and climate over this, what we call the Phanerozoic. And during the Phanerozoic, what Jan has shown is that we've had a series of ice houses and greenhouses. So we've had ice ages and hot houses or warm periods on a rather cyclical time scale over this 500 million year period. But when we look at the correlation with CO2, we see high CO2, and these are various models of CO2 concentrations in the atmosphere. This is a log scale, so at number 1 we're looking at a 10-fold increase of CO2 over today. And so back during our Ordovician glaciation, we had very high CO2. During the Carboniferous, it comes down. This is when we created all these coal beds in North America, and CO2 went by sequestration. Here's another Jurassic ice age, and CO2 is 5 to 10 times higher than today. So even over this time frame, we do not see a correlation with CO2. We do not see CO2 as a climate driver. But we do see this if we look at the model projections going into the future. Here I'm showing the IPCC model projections from the year 2000 over the next 100 years. And they all climb by about 2 to 3 to 4 degrees Celsius, and these are significant increases in temperatures. How do they model the greenhouse to achieve these temperatures? Well, CO2 is a very minor greenhouse gas. It's a very minor constituent of the atmosphere. It is by far a strong greenhouse gas. The strongest by far is water vapor. And so water vapor is used in these models to drive climate warming. The concept or the model is based on a little bit of CO2 warming, which would be insignificant, is amplified by water vapor, a 2 to 4 time water vapor feedback. And this feedback effect has never been documented. It's never been seen in the geological record. And so it remains an hypothesis that we've based all of our predictions, and this is the only reason why we're predicting global warming. Do the models work? Well, as my colleague Ross McKitrick
Can I just interject 1 second here? I apologize, sir.
No problem.
As you, I think, know, we're being broadcast on the CPAC network and also on the World Wide
I
Web.
understand.
And these overheads that you're referring to in your testimony and almost continually are not being shown, unfortunately, on the networks because they're not bilingual. And that's one of our inviolable rules here in the Senate. So,
I understand.
But I think your narrative still makes them understandable.
I have written a testimony
Yeah.
that should be published as well.
At some point, sir, you might just, again, we're not all scientists here, only one of us, and not me. You keep talking about greenhouse gases on the one hand, and then you say CO2 is a greenhouse gas, and then H2O factor. Just what? There's a colloquialism out there in the world that's become part of our regular vocabulary, greenhouse gases. But I don't think anybody really knows what they're saying when they say it.
Can I
so if you
describe
could
that?
give a definition, it'd be great.
Absolutely. Thank you very much. The planet, and these are the slides that I cut from my talk, the planet without what we call greenhouse gases, with just a transparent atmosphere of nitrogen and oxygen, would be about 32 degrees colder than today. We'd have a planet which would be unlivable, it would be frozen. Thanks to one greenhouse gas, which is water vapor, and what water vapor does in the atmosphere is it absorbs the outgoing radiation. When we warm the planet with solar radiation during the day, it emits that radiation throughout the day and throughout the night. So the planet cools. If we trap that outgoing radiation, what we call long-wave radiation or infrared radiation, like what you see on the hot plates in fast food restaurants, the heat is retained in the atmosphere and warms the Earth's surface. So we retain a planet which is now 14 degrees above zero and habitable. CO2 represents a couple % of that greenhouse gas effect. It's a very minor greenhouse gas. Water does all the work. So when we talk about the greenhouse gases in the atmosphere and accumulating greenhouse gases in the atmosphere, and we focus on CO2, we're being deceptive because CO2 cannot give us the warming that has been projected. So to project warming, if we feel we have to account for the past century's warming and project that into the future with CO2, we are obliged to amplify that with water vapor. So my graph with a little arrow of CO2 is making the water vapor cycle work. It's preposterous. CO2 is a very minor greenhouse gas, and we're attributing it all the power in the world to move water vapor around as it will. Preposterous. Okay, I'm closing in on the final here. So the models predict, as Ross pointed out, a hot spot, and this is the classic response of our planet, or should be, to an enhanced greenhouse effect, where we have between the latitudes of 30 north and 30 south at about 12 kilometers in the troposphere, a thumbprint of warming. This is our fingerprint, our thumbprint of greenhouse warming, according to the models, the numerical models that we're told to believe. If we look at the radial sound measurements, these are balloon-based temperature readings, there is no hot spot. In fact, we have cooling. So we might suggest that the models are incorrect. And then we can ask, well, what do the people who run these models say? And here's what they say. And these are the famous leaked emails, which we get an insight to the thinking of the people who are warning us about catastrophic global warming. Thorne from the Met Office at the Climate Research Unit says, observations do not show rising temperatures throughout the tropical troposphere. This is downright dangerous. We need to communicate the uncertainty and be honest. Phil Jones, who keeps the temperature records, hopefully we can find time to discuss this. Phil Jones responds, the basic problem is that all models are wrong. There's not enough middle and low-level clouds, i.e., they cannot model water vapor and cloud formation. And then Wilson pipes in, well, what if climate change appears just to be mainly a multi-decadal natural fluctuation? They'll kill us probably. These people have great uncertainty in their work, but we don't see that when they present it in the IPCC documents. So what is driving global warming? Well, we have to look at the sun. And we have, unlike CO2, very good correlations between solar activity, various measures of solar activity, and temperature. Here again in the Arctic, where Arctic temperatures, and there's all our melting in the Arctic, correlating with solar activity, but not with CO2. And I'll show one last bit of research done by Solanki, published in Nature, where he points out that during the recent decades, the sun's activity has been greater compared to the last 11,000 years. And here's his graph showing a proxy of solar activity over 11,000 years, and it has peaked in the past 20th century when we see this 20th century warming. Well, let's zero in on that last little bit. And here's the last 1,000 years. And here's a bona fide temperature record from the Greenland ice core, a very robust temperature record in blue. And it correlates very well with our solar activity. So we have a reason that our climate is warming. It's not CO2. And if I can just summarize, we find that there's no geological evidence that CO2 has behaved in the past as a significant forcing mechanism. CO2 remains at the lowest level today, range than observed over geological time. I'd like to add that it's more than a benign gas. It's an essential nutrient for life with only beneficial effects. And our efforts to limit the use of fossil, carbon-based energy has solved no environmental problems, yet has created many more, including the accelerated production of ethanol and the conversion of tropical rainforest to tropical palm oil production. And my feeling is that it's time that we turn our attention to real and tangible environmental problems. And thank you very much.
Well, thank you. That's another very candid explanation for us. Next presenter, Professor Jan Veizer. Professor Emeritus, Department of Earth Sciences at the University of Ottawa. So you two gentlemen, Professor Clark and Professor Veizer, you work together at the department at U of O?
For the last, prior to my retirement, for the last 15 or 20 years, I was professor both in Germany and at the University of Ottawa. I was also 20 years director of the Earth System Evolution Program of the Canadian Institute for Advanced Research. And I am retired, or supposedly retired, since 1974. But that's my attitude to retirement is like Woody Allen to dying. He said he's not afraid of dying, but he just doesn't want to be there when it happens. So, well, Mr. Chairman, committee members, many people think that the science of climate change is settled. It isn't. And the issue is not whether there has been an overall warming during the past century. There has. Also, it was not uniform, and none was observed during the past decade. The geologic record provides us with abundant evidence for such perpetual natural climate variability, from ice caps reaching the equator to none at all, even at the poles. The climate debate is in reality not about carbon dioxide, but about 1.6 watts per square meter discrepancy, or this kind of uncertainty in a poorly known planetary energy balance. This is an absolute fundamental statement to start with. Okay? So let me explain. Without our atmosphere, the planet would be frozen ice ball. Natural greenhouse warming is warming it up by 33 degrees C. Next, 2/3 of this warming, or more, up to, well, perhaps even 95% of this warming is really due to water vapor, not to CO2. Okay? So water vapor, not carbon dioxide, is by far the most important greenhouse gas. Yet what the models do, they treat the water cycle as just being there, relegating to a passive agent in the climate system. The energy that is then required to drive water cycle must therefore come from somewhere else. The sun, the sun which drives the water cycle then generates climate, and climate decides how much jungle, how much tundra and so on we will have, and therefore drives around the carbon cycle. This would, this would be the top-down model, that means driving in through the climate. Or it can be the way the IPCC does it. It says no, it's bottom-up being driven. Carbon cycle is putting a bit energy into water cycle, then it generates more activity, then it generates even more and more and more and more activity. It's like saying that it is, Puerto Rico is driving the world economy by positive feedback from the United States, because when they put a bit of, when Puerto Rico increases its GDP by 10%, then what happens is that some of it will come into the US, there will be more economic activity, therefore more finances, more economic activity, more finances, more economic activity, more finances, until you get boom, and then you get world economic boom. Well, the point is that Puerto Rico is piggybacking on the United States, and is subsidized by the United States, not driving it. Okay? So you have top-down or bottom-up situation. So the energy that is required to drive the water cycle must therefore come either from here, or from any possible way, possible combination of the above. Note that because of the overwhelming importance of water vapor to the greenhouse effect, existing climate models are not diagnostic. To the water cycle, energy is just that, energy, regardless where does it come from. The water cycle doesn't know. It's energy for it, okay? So, as documented by previous speakers, the past climate record does indeed resemble the trend in solar output. However, because the 3 decades of satellite data show only limited solar variability, the solar output would have to be somewhat amplified to explain the magnitude of the centennial warming. The IPCC argues that because no amplifier is known, which is an invalid assertion, man-made greenhouse gases must be responsible for most of the energy imbalance. In other words, they say, they say that this is more or less a constant, sun is a constant, therefore it has to go bottom up. Okay, that's what it says. But this is an assumption, an attribution by default. Okay? Not an actual empirical or experimental proof that carbon dioxide is a driver. Yet, such attribution is then taken in all subsequent complex model calibration of climate as a fact. And this is what is called calibration. If an amplifier to solar output does exist, an empirical observation detailed in the submitted article, which I put up here, argue for its existence, the need to attribute the energy to greenhouse gases would diminish accordingly. Okay? So, how realistic is the basic model assumption that the tiny biologically controlled cycle, the carbon cycle, drives the climate via the passively responding huge water cycle? How realistic is it that Puerto Rico is driving the world economy by US, pushing around US? Okay? Our nature tells us that, in fact, it is the other way around. Surely, the blossoming of plants in the spring is the outcome, not the cause of warming sun and abundant rain. Okay? So our atmosphere contains about 730 billion tons of carbon. Each year, about 120 billion tons are cycled via plants on land and about 90 through the oceans. It's absolutely dominant. The human emission account for less than the 5% of annual carbon cycle. Okay?
Less than how much?
5%.
Five.
From the point of view of interaction of water and carbon cycle, however, it is important to realize, that, that for every single, we are supposed to plant the trees to lower the CO2, but for every single molecule of CO2 that plant has to transpire into the atmosphere, water from the soil, from the roots, 1,000 molecules of water for every single CO2. So this is a huge amount of energy required to lift the water back into the canopy, from the canopy back into the atmosphere. And the actual reaction is one CO2 for one water to generate the transpiration, to generate the photosynthesis. The rest, actually the entire energy is not needed for this photosynthesis. Practically the entire energy is to drive the water cycle up to the atmosphere, to drive that water conveyor belt. Why is it? Because this is what brings you the food. This is your conveyor belt which is bringing you the food, the nutrients. No food, no life, no carbon cycle. Okay? So, in other words, the required huge energy source is the sun. Solar energy drives the water cycle, generating warmer and wetter climate, and invigorating the biological carbon cycle. The sun also warms the oceans that emit the CO2 into the atmosphere. So atmospheric CO2 is thus a product and not the cause of the climate, as demonstrated by the past records, where temperature changes always precede changes in atmospheric CO2. Ice cores, as Jan was showing you, is the case. The same happened after Pinatubo eruption. At first cooled, and then started CO2 fluxes change, and it happens every spring. It's sun shining first, and then flowers bloom. Okay, so so what might be the complementary source of energy that could account for the disputed 1.6 watts? Clouds. Clouds are mirror that reflect solar radiation back into space. The amount of solar energy reflected by the Earth is about 77 watts. And the difference between cloudy and cloudless skies is almost 30 watts. Okay? So change of few percent in cloudiness can easily account for 1.6 watts, what is being disputed. Okay? So clouds are an integral part of the water cycle. But formation of water droplets requires seeding. That's like in Beijing, they had to shoot into the clouds, okay? It requires seeding. Empirical and experimental results suggest that cosmic rays hitting the atmosphere may generate such initial seeds. While the actual mechanism is still debated, the correlation between cloudiness and cosmic rays have been published. Okay? These are measurements. The amplifying connection then to the sun probably comes via its electromagnetic envelope, which is called heliosphere, and a similar envelope around the Earth called the magnetosphere. These act as shields against lethal cosmic rays reaching our planet. A less active sun is not only colder, but its heliospheric shield shrinks, and there are more cosmic rays coming through, and they seed more clouds, and they also produce cosmogenic nuclides, the beryllium-10, carbon-14, which we can then measure in trees, rocks, and so on. So this is a measure of the activity of the sun, really. When there is weaker sun, we have more of those cosmogenic nuclides. So cosmic rays, when hitting the atmosphere, if you look at the record for such a record for the past 10,000 years, next slide, So what you see here, this is a record of the blue is a record of climate over the last 10,000 years. And this is the record of carbon-14. This is those cosmic rays which you are talking to, which are due to cosmic rays and which reflect the activity of the sun. If you look, next slide, on the CO2, CO2 was flat all the time, and this is the climate at about 280 parts per million, exactly like with the so-called pre-industrial level. So the science of climate change continues to evolve, and regardless of the outcome of the climate debate, observational data suggest that we may be served well by basing our climate agenda scientifically and economically on a broader perspective than that in the IPCC outlined scenarios. Okay? These are one scenario, but there is more to it than just IPCC. Our pollution statement and energy diversification goals can then be formulated and likely implemented with less pain. Thank you.
Well, I congratulate you, sir. You were exactly 10 minutes, and that's scientific and well presented. Thank you very much. And our fourth presenter this morning is Professor Timothy Patterson, Professor of Geology, Department of Earth Sciences at Carleton University. Over to you, Professor
Thank you
Patterson.
very much, Mr. Chairman, committee members. Thank you for the opportunity to testify this morning. My interest in the climate change debate was triggered in 1998 when I was funded by an INSERC strategic project grant and subsequently by major funding from the Canadian Foundation for Climate and Atmospheric Sciences to determine if there were regular cycles in fish productivity on the Canadian West Coast. Although climate was suspected to play a significant role in marine productivity, accurate fishing and temperature records have only been kept in that region for about 70 years. And we needed indicators of fish productivity over thousands of years to see whether there were recurring cycles in populations and what phenomena might be driving these changes. My research team collected and analyzed core samples from the bottom of deep coastal British Columbia fjords, and we collected more than 5,000 years' worth of annually deposited mud layers from these basins, and that was giving us one of the highest quality climate records available anywhere today. In it, we see confirmation that natural climate causes can be quite dramatic. And just as an example, in the middle of a 62-year slice of the record, about 4,400 years ago, there was a shift in climate in only a couple of seasons that went from very warm, dry and sunny conditions to a regime that was mostly cold and rainy, and that persisted for several decades. You might imagine what impact that might have had upon Amerindian populations in the region. It might be fishing, dependent on fish. It would changed their life completely. In that record, we've discovered repeated cycles in marine productivity that correlate very well with cycles in the brightness of the sun. And this was not unique. And hundreds of other studies have shown exactly the same thing, that the sun, and not variations in carbon dioxide, the gas that's most targeted by Canada's national climate change campaigns, appears to be the most important driver of climate change. Solar scientists predict that by later in this decade, the sun will be starting into its weakest solar cycle of the past 2 centuries. And this will likely lead to unusually cool conditions on Earth, which may persist for decades. And planning for adaptation to such a cool period should be the primary position for governments. And it's global cooling, not warming, that is the major climate threat to the world. And this is particularly true for Canada, with such a high latitude nation as we have, where agriculture is right at the edge of where we can farm. Through another INSERC strategic project grant that I currently head up, my research team is studying climate variability in northern Canada, so as to advise government and industry about the long-term viability of the strategically important Tibet to Contwoito winter ice road. This seasonal ice road is critical to the economy of the region, as is the only overland route that services the diamond mines and exploration camps in the central Northwest Territories and southern Nunavut. Beginning 70 kilometers north of Yellowknife, this world-renowned ice superhighway that you may have seen on Ice Road Truckers television series traverses 600 kilometers, and 88% of it is built over frozen lakes with little fjords or little portages in between.
So, Senator Patterson, this would be familiar territory for you? You've driven the road, does exist? So you're confirming that?
On that road, yes.
but how much
Fished on that road.
Thank you.
Listen further, and I'll tell you how much longer. During the 70-day season, more than $500 million in equipment and supplies are carried to the camps. And the economic activity associated with the operation of the ice road contributes over $1 billion to the economy of the Northwest Territories every year. And for remote northern Canadian communities, similar ice roads are very critical supply links. In our research, conducted every year in latter part of March, when activity in the ice road is starting to diminish and we have access to the camps along the way, we collect ice core samples from lakes along the route. And by comparing lake sediment of the past 3,500 years, we are able to recognize cycles and trends impacting climate change, and from that we can predict possible future trends in climate, ice cover, and things like fire hazard. We can recognize in their intervals in the past when it's been warmer and drier, and so on. It's a particularly challenging task in this region, as the short thermometer record only extends back to about 1950. And it is in the central Northwest Territories, includes records from only 4 very widely spaced meteorological stations. Preliminary results from our research indicate that considerable climate variability has existed through the last few thousand years, with winter and summer temperatures often becoming decoupled. A multi-decadal weather phenomena known as the Pacific Decadal Oscillation, which is a huge driver of climate. It's a lot, very similar to the shorter but better known El Nino phenomenon. It was only discovered in 1996, so it shows you how climate research has changed over the last 20 years or so. It seems to have contributed to the stepwise temperature changes, as these phenomena vary between positive and negative phases. There's also a correspondence between solar cycles and seasonal climate variability during negative Pacific Decadal Oscillation phases, with solar cycle troughs corresponding to colder winters. As we are about to head into a series of very weak solar cycles that are going to persist for several decades, and since the Pacific Decadal Oscillation, again this decadal scale phenomena, has just shifted to negative, we project a period spanning several decades where conditions will remain suitable for continued extensive use of the ice road. As I am sure you have concluded from our testimonies today, the field of climate science is vast and rapidly evolving. Many things that we thought we knew about climate system just a few years ago are now proving to be highly uncertain or quite mistaken. It's no exaggeration to say that in the period since the Kyoto Protocol was introduced, there's been a revolution in climate science. If back in the mid-1990s we had known what we know about climate change today, there would have been no Kyoto Protocol, because it would have been considered unnecessary. In some fields, the science is indeed settled, but the science of global climate change is still in its infancy, with many thousands of papers published every year. Thank you, Mr. Chairman and committee members, and I look forward to answering any questions you have. Thank you.
Thank you, Professor. You were able to get it done in 6 minutes and 28 seconds.
5 minutes.
They were shortchanging you. Anyway, fascinating stuff. Colleagues, first of all, we have presentations from each of these witnesses which had to be sent to translation. They'll be, when they're ready, they'll be posted on our committee's website. So they'll be available there. Of course, so will the transcripts. Now we go to our resident climate change expert, Senator Grant Mitchell from Alberta.
Well, Mr. Chair, I think what I'll do is I'll defer to our colleagues. I generally get to ask first, but maybe I'll wrap up or come in later.
Okay, whatever you like. It's normal that you have the first kick at the can. I've got Senator Daniel Lang from Whitehorse.
Thank you, Mr. Chairman. I want to say, first of all, thanks for coming, and it certainly is interesting to hear the viewpoint that you're bringing forward here into the public forum. It's not a viewpoint that we've heard much of in view of the political spin that's put on climate change over the last number of decades. And I'd like to ask Dr. McKitrick a question, if I could, because of your vast experience and involvement with the IPCC, I believe it's referred to. They think the concern that the world should have, and we as Canadians should have, is that there is there has been an intention to just bring forward one scientific political message to the world. And my understanding is there is really a lot of question whether it has merit or how much merit it does have. And I also know that in a lot of the science, what is seen as bona fide science publications, the information that's been provided through the United Nations in some cases has been accepted as gospel and not necessarily been peer-reviewed, but accepted as peer-reviewed. I want to ask you, what has to be done to change that so that there is a legitimate public debate based on valid information so that we as citizens of the world can understand what's taking place?
I would refer to the report that I submitted, which includes a list of recommendations for changes to the IPCC process. I think something like the Intergovernmental Panel on Climate Change is necessary because you do need some way of bridging this enormous scientific field and presenting information in a usable format to policymakers. The danger is that when you create an organization like that, and then it takes upon itself the role of speaking on behalf of a very large scientific community, and you don't have a chance to sort of look and see what the process is that they're using, then that gives them a lot of power without proper accountability. So the reforms that I've proposed would really work to get the IPCC operating more in the way that people assume it does, but which is actually quite a long way from how it in fact operates. The difficulty is the IPCC is controlled by a plenary of 195 country delegates, and the vast majority of them, having reviewed the records from some of the recent meetings, most of those delegates don't appear even to read the briefing papers. They don't put in any comments. They don't participate in any active way. Most countries did not submit any review comments on the last assessment report. Of the comments that were received, half of them came from only two countries, the United States and Australia, which are also the countries that refused to ratify the Kyoto Protocol. That's a body that requires some oversight, and Canada has a voice in that plenary panel. Canada sends delegates to it. During the last reform process, Canada was one of the only countries that tried to toughen up the procedures of the IPCC. I don't think they got anywhere because there just wasn't the interest on the part of other countries. But where I would begin would be to find out who is Canada's focal point for the IPCC and to get a group of countries interested in beginning the process of reform. If you had a group of countries in the plenary who sat down and talked it through and realized, if we're going to have an IPCC, let's at least make it work properly, and then as a group take it to the plenary, I do think you could get some reforms in place. If that failed, then I would say that Canada and some other countries should just set up its own advisory process and leave the IPCC aside.
Thank you, Mr.
Senator Green?
Just a supplementary. You said, thank you. The 100 delegates from 100 different countries, I presume these are scientists appointed because of their expertise in climate science?
No, these are government bureaucrats. Some of them might have the scientific background, but these are bureaucratic delegates to a plenary panel. It's 195 member countries. The scientists who write the reports, that's a separate group. Those are the working groups. Those are the lead authors that I mentioned. They're selected by the Bureau in Geneva. One of the most prominent criticisms in my report, but also from the Inter-Academy Council, was there are no procedures stated for selecting lead authors. Every few years, the IPCC just publishes a list. Nobody's quite sure how they come up with it. They just announce these are the lead authors for the next report. They have complete control over who they select. And as far as I know, the member countries like Canada, although Canada can make suggestions like any other country, we don't have any direct say over that decision. So the lead authors are in what are called the working groups. The plenary panel, which is supposed to be the group that has the oversight, those are not scientists.
Thank you.
Thank you, Senator Rain. Are you finished? No.
Just one further question, and I would, Dr. Patterson, if I could. You spoke about the situation in Northwest Territories, and contrary to what we have been led to believe, that we are looking forever and a day at global warming in view of the man-made emissions of CO2 and greenhouse gas emissions. You stated that we're going to be going into a long period of cooling, and that has to be a very major concern to Canada if that's the case, and we have to plan according. Maybe could you please expand on that, and perhaps maybe give us some indication of what we should be doing as a country, planning for that, if we accept that premise?
Okay. Certainly. This is basically my research in the Northwest Territories. It's funded by INSERC and basically in partnership with the Tippecanoe Winter Road, the North Slave Métis Alliance, and various other groups with an interest in the long-term viability. So we don't really have a particular axe to grind. We're doing there from a very applied perspective, trying to understand what the nature of climate is, particularly with the diamond mines that need to transport their materials out and equipment north, and now there's talk of more mines trying to bring massive sulfides down the ice road and so on. So they really need to know, and building a fixed link across that region is very expensive to do this. So this is why we're doing our research that we've been able to do. We're able to collect cores and analyze the record. It's at the highest resolution that's ever been done. We use a new technology we developed that we can actually look at annual resolution changes in climate change in the Northwest Territories, which has not been done before. And there's been very little research done. So we basically have been breaking new ground. And so we can recognize that there has been enormous climate variability in this region over the last few thousand years. There's a big reason why our project only looks at the last 3,500 years. If we went further back in time, it was considerably warmer than it is today. So it's not very useful if you're trying to figure out the current climate situation to go deeper in time. So basically our projections then are based on trying to understand these cycles, and what we now know from some of the groundbreaking research has been done by people like Jan Veizer and so on in the last few years that basically have really changed our understanding of the dynamics between solar forcing, carbon dioxide, water vapor, and so on, and trying to understand what's going to go on. But from the perspective of where we might be going in here, this is something of great concern to Canada. Particularly, everybody always is talking about warming and so on, but because we are at the north end of agriculture in Canada, and there's not a whole lot of wheat production going on in the Northwest Territories at the present time, and basically, if things start to cool off, you start to threaten your production in Western Canada and so on, and if it's happening to us, it's happening to places in Eastern Europe, would be worse, and so on, if the world is starting to cool down. So we have to really think about various sorts of adaptation strategies, not only just warming, but you have to think about what might be happening if things start to cool down from the social unrest perspective and everything else that goes along with it. We're a big country. We could probably adapt to lots of changes. Our farmers are very efficient, and they can adapt to changes on a dime. If things warmed up, they can adapt their agriculture probably very, very quickly. But if things cool down, you just can't make things grow if the seasons are too short. And so all we ask is that people start to look at what the possibility might be. And my reports are going forward now about for the ice road is that we project that through the next few decades it probably be pretty good conditions for the continued use of this road.
Mr. Chairman.
Just want to say at this time last week, some of the members of the committee were in Regina, Saskatchewan, holding hearings. It was 28 below zero with the wind chill. That's warming to me.
It was minus 36 when I was in Yellowknife a couple of weeks ago.
Well, there you have it. Senator Brown has been giggling away over there. You have the floor, Bert.
Yeah, I've felt like it's kind of an insult to be a denier for a long time. It feels pretty good this morning. I've read a lot about different things in climate change ever since I came to the Senate. One was from a book by a geologist that says that we've been having climate change for 18,000 years, and that's only because the cores that they could find were 18,000 years old. So it must have been changing ever since the dinosaurs, I guess. I've always thought the sun was the biggest driver of whatever happens in the world. And I did read in some place that there's a elliptical ride around the solar, the planets that revolve around the sun. And every so often they kind of line up a little bit closer to a line next to the sun, and that is supposedly causes different changes in the temperature that the Earth gets, because it pulls it into an ellipse instead of a perfect circle around the sun. Is there any scientific stuff behind that, or would you just say that it's not possible?
Absolutely. There's a terrific scientific background for that. These are called the Milankovitch cycles. And Milutin Milankovitch worked these out mathematically by studying the geometries of the of our entire solar system, the planetary orbits around the sun, and their impacts on the gravitational pull with respect to the Earth and the Earth-Sun system. And there's actually three effects, and you quite correctly point out that our orbit around the sun goes from an ellipse to a more circular orbit. But in addition to that, we're like a top that's starting to precess. And so our pole, which currently points towards the North Pole, North Star today, didn't 11,000 years ago. It was off axis with that North Pole because we're tilting. And that doesn't seem to, why would that affect anything? Well, whether we're pointed towards the sun when we're in an elliptical orbit, so we're now far away from the sun or we're close to the sun, and where our pole faces, that'll define how much energy we receive on a seasonal basis. And so these are very important processes. It comes back to the sun. It comes back to how much solar insolation we receive, but it distributes it, or we see a variability in its distribution with latitude. So at sometimes we'll have, we're close to the sun, what we call the perihelion, when we're pointed towards the sun. So we have our hot summers in the northern hemisphere and cold winters, and that'll switch after another 11,000 years till we have mild summers and mild winters, and these have a terrific impact, and we find very good correlations. In fact, these are the effects that really define the ice ages. So it's solar radiation, but it's the variability or the evolution of solar radiation with respect to latitude. And so these are well documented, and we see these cycles appearing in many, many terrestrial records. And it comes back to how much solar radiation we receive at different latitudes and at different times of the year. So you're absolutely correct. There's very strong science behind that.
Thank you. I'd forgotten to speak about the tipping of the polar things. They actually said that was what caused
you're quite right.
In the North Pole one time and colder in the South Pole, and it can reverse when it straightens out again.
There's actually those three cycles. So you just brought up the one that I overlooked, which is the inclination or obliquity. So our Earth's axis, rotational axis, actually, in addition to wobbling like a top, it goes over more and comes back up more. So we're more oblique. The pole is closer, more directly pointed towards the sun, or back in this has it's actually a 41,000 year cycle. So we have three processes working in concert, which makes it very complicated. So the graph that I showed of the ice core temperature record, it's pretty erratic, and that's all these cycles coming into play.
Thank you very much to all four of you. I really appreciate it.
Thank you, Senator Brown. We're going to call you the senator from Milankovitch next. We'll have Senator Massicut.
Chair, thank you for being with us today. Obviously, our self-interest as individuals and as representative of our parliamentarians in Canada, we'd love to believe what you're saying is accurate, but I'm sure you can appreciate this is highly technical, and we're not a very good judge of whether you're right or wrong. But what is very, very good and healthy is this debate. I mean, scientists should be debating, contesting each other constantly. That's what allows the cream to rise to the top, and that's where truth will, and certainty which we'll never get to, but I guess science is an issue of probabilities, and let's hope you cause this audience to be heard and continue with your good debate. Having said that, though, as a non-expert, as you can appreciate, I'm sure, we must rely upon the preponderance of evidence and preponderance of scientists as to what their opinion are. And all we can do is encourage the debate and see what the result is when your ideas are contested with other scientists in the world. And having said that, I'm sure you acknowledge that the great majority of scientists don't agree with your conclusions. They probably appreciate some of your data, but they don't agree. And that's the observation we could only make, because we're not able enough to decipher all this stuff. Having said that, what audience have you received? What is the process that you've made public your ideas and what audience are you getting there? Are you making progress? And why is it that you haven't convinced the great majority of other scientists of your views? What's the process, and you're pleased with that process? So I'm not sure who wants to make a comment.
Can I? One of the issues that you heard about was the water vapor feedback effect, and the water vapor feedback effect in the models gets concentrated in the troposphere over the tropics, and there aren't a lot of papers on that topic in the literature, but there are really two identifiable groups that have been disputing it. A study that I was a co-author on that was published last year used proper statistical methods to look at the data sets and the climate models. This was published in a good atmospheric science journal. And we were able to show that the discrepancy is real between models and observations, that the models significantly overpredict the warming that's going on there. What was interesting in the new batch of climate science emails was to read from some of the people on the other team who, although they won't say it in public, in private, are acknowledging that this is a problem for them, that there is no warming. And one of them even pointed out that, if anything, it's a cooling in that record. And I mentioned one of them described it as living in a fool's paradise, and they used the phrase, it's dangerous, that we're trying to carry on with this impression. So I can completely understand your position as a decision maker. What do you make of the fact that you've got this institution like the IPCC and its various satellite organizations that tells you one thing, and then you keep hearing rumors of other relevant points of view? That's why I would like to shift the discussion a little bit onto getting people to understand more about what the IPCC actually is. I don't think it's as representative of scientific opinion as it's been made out to be. And also, in terms of what you should listen to, at the end of the day, it's not the authority of a scientist or the authority of anyone here. It's really the data. What are you supposed to be measuring? If we were talking about inflation or interest rates, we could say whatever we like, but you can look it up. You can look up the numbers and see for yourself. And I think that's a question that you can put to the scientists that you see. What are you predicting? How do we measure it? And what do those measurements show? Because that's what should be speaking the loudest.
Appreciate that. But even in inflation, there's a constant debate with basket of goods included. Nothing's certain, as you know. In fact, we can get the long argument. How about our own? Every country, our self-interest. We would love to agree with you. In fact, human nature is such. Some of us will quickly agree with you because that's what we'd love to hear. But most countries, including our own scientists, we're spending a lot of money as a country, and many countries are spending a lot of money because of the preponderance of evidence that they heard. And our own Minister of Environment recently said that the scientists within our own government agree with climate change, which is man-made, which is obviously a critical issue. But what you're seeming to be saying is, I think you mentioned the word, there's an elitist bias and there's momentum towards this common agreement. But I think the opposite. The bias would be, boy, they'd love to agree with you, and they would love to find what you're doing is right and save all these billions of dollars we're saving. And why is it that even the bureaucrat, which doesn't have a bias, why won't they come out and say, we agree with you, this is all wrong?
Well, I can't speak for individual bureaucrats, but between the academic community and the government science community, there is a lot less freedom for government scientists to speak. I don't put a lot of stock in the idea that that someone would say all these experts all agree with a certain point of view when it's basically it's the person signing their paycheck is telling you that. How much freedom do they have to really speak out? I'm more familiar with the academic world where people have quite a bit more freedom to speak out, and I can just say among my colleagues there's lively discussion, there's a wide range of perspectives, and within people's own area of expertise they still have lots of questions about what's going on.
It's a tough one. I appreciate it. I think many people will dispute it. In fact, I think the most reasoned mind will say, you're right, we're not 100% sure this is occurring. I think nearly nobody is 100% sure. But like many decisions we do in life, we deal with high probabilities. I cross the street, but I have to look both sides and think I won't get hit. But maybe I should look 3-4 times. Nothing is certain. And therefore, many people's attitude, and I think the one that resumes best my opinion, the economist basically says we're not 100% sure climate change, but it's going to cost us 1.7 in GDP if we make the measures. If we don't measure it, if we don't do it, it's going to probably cost 5 to 10. Maybe it's 1.7, 1.9% we're wasting, but it's like an insurance policy. So they seem to acknowledge the uncertainty of the event, but it's money well spent, because what if we're wrong? It's a huge impact. You want to make a comment on that reasoning there?
And what if we are wrong the other way? How much is this going to cost us?
It's 1.7.
Also, the 1.7, there have been a lot of studies about what it would cost Canada and other countries. That 1.7 doesn't mean 1.7% of GDP to eliminate the threat of climate change. That's 1.7% of GDP to, say, reach the Kyoto target. And what would that buy you? If the models are right, it only slows the process down by 5%. So if you want to do it on a cost-benefit test, you need to be careful to make the comparison of what it is that you're actually buying with the policy. Because otherwise,
Thank you, Chair.
Did you have a supplementary, Senator Lang? Short.
Very, very quickly, talking about certainty, it would seem to me that one thing is certain is that we wake up in the morning with a thermometer and we know how cold or how warm it is. And we have 365 days a year that thermometer is registered. So surely we can at the end of the year say whether the world's cooling or it's not cooling. Perhaps you could comment on that.
Well, that's a very difficult problem, and I think Ross is perhaps the best person to talk about that. So I'm going to turn it over to you, Ross. But it's a very difficult measurement, the global temperature measurement. What is that?
there are a couple of different key databases. One is the land surface temperature record, which I think has the biggest quality problems, but it's the one that is most prominently displayed. Better quality data sets come from weather satellites. Weather balloons is another source. And then Canada was also a big supporter of something called the Argo network, which is a network of 3,000 robotic floats that now travel the world's oceans, taking constant temperature readings down to a depth of about 900 meters all the way up to the surface. That's a much better quality ocean temperature data set than was available, but that only goes back to 2003. I've worked mostly with the satellite data sets because I think they're the best quality temperature data sets that we have, and they measure the region of the atmosphere where the greenhouse gases mix and the effects should be most evident. And it's the big controversy has been the fact that there's a lot more warming. There seems to be more warming at the surface than in the weather satellite data sets, and the models don't predict that discrepancy should be there. In terms of what we monitor, I think now there's a lot more attention being paid to the weather satellite data, and it's updated monthly, and that's where you begin to get the idea that to the extent there's warming, it just doesn't seem to be on the scale of what the models have predicted.
Thank you for that clarification. Senator Banks.
Thank you, Chair. As I think everybody knows, and as the exchange between Senator Massicotte and Professor McKitrick showed, we are not experts. We have the privilege of listening to experts, and we've been doing that for 2.5 years, well, longer than that in some cases. But it will fall to us to make a decision of some kind. So we have to base our decisions on the evidence that we've heard from experts, from people who either know or who purport to know, that we find the most compelling. One of the things that I think we would all agree on, and you have demonstrated, is that there is climate change. The question, with respect to Mr. Gore and others like him, boils down to the extent to which and how much, if any, we are contributing to it. And some of the evidence we've heard is that there's an exponential difference between what we're doing and what we are emitting that has occurred in about the last 100 or 150 years. That has, to some degree, skewed the question of how much are we having an effect on it. We have learned that all predictions are wrong, that all models are wrong, because the slightest deviation from them at the beginning becomes a very wide deviation when you go out sometimes weeks, sometimes decades, sometimes centuries. I personally believe in the precautionary principle to which Senator Massicott referred. If I see that train coming down the road 90 miles an hour at me and nobody can absolutely prove that it's going to hit me, I will nonetheless probably take some evasive action, despite the fact that there isn't proof that it's going to hit me. So there are four basic scenarios based on the extremes that might help us decide what we're going to do. One is that we do nothing. I'm talking about extremes. We do nothing by way of mitigation. And at the same extreme, nothing happens. Everything's okay. There's no bad effect of climate change, or at least nothing that we can affect. If we place that bet, that's a big winner. We win all around. The second scenario is we do nothing, and the worst happens. And we have, as a result, an unlivable world. We leave our great-grandchildren in a situation in which they will be, at the very least, a lot less comfortable and perhaps in some difficulty. That's a big loser bet. The third possibility is we do everything. We spend ourselves into the poorhouse by trying to mitigate. Remember, we're talking about extremes. And nothing happens. We spend all that money, and it's a complete waste of money because we didn't have anything to do with it in the first place, and whatever's going to happen. That's a big loser. And the fourth scenario is we spend ourselves into the poorhouse trying to mitigate, and as a result, we save the world from what would otherwise have been a terrible disaster. That's a big win. We have economic chaos at the extreme, because we will have spent ourselves into the poorhouse, but we will have saved the world. So the two bets that are good ones are we do nothing, and nothing happens. That's bad. That's a good bet. And the other one is that we do everything and spend ourselves crazy and ruin our economies, but as a result, we save the world. Which, for our grandchildren and our great-grandchildren, from ecological disaster, where would we place our bet?
You've outlined what makes this a really impossible decision. I mean, I completely understand that you would throw up your hands and say you don't like any of the above. What I've proposed from an economic point of view is just maybe as a thought experiment, but you could actually do it. Suppose that you put a small carbon tax in place, and then you tied the value of that carbon tax to the atmospheric temperature measurements we get from weather satellites. Now, people are going to have to start forecasting what's going to happen to that tax. If they believe what you've heard today, they're going to say, well, that tax isn't going to go up, it might even go down, and so we're not going to worry about it. If they believe what the other group of scientists say, then they'll think, okay, that's going to start trending up pretty steeply in the next few years, so we better start changing our investment plans. You would, in effect, force people to decide what's the most credible story and build that into their decision making starting today. But you wouldn't have had to commit one way or the other to who's right. Basically, you'd be making a choice that at the end of the day, you were right however it comes out. So if after 20 years the tax hasn't gone up, you can say, well, we didn't waste a lot of money on a non-problem, and if the tax did go up and people had to scale back their energy consumption, you can say, well, we got that one right, didn't we? So
being right, whatever the outcome, is a thing that's very attractive to politicians.
Sorry.
Yes, please do, sir.
Okay, I was
Yeah.
just going to say, well, but what if it gets colder? And so that's another scenario that we need to really think about. And,
Well, we've been very careful to talk about climate change, not global
yeah.
warming.
But one thing, for example, from my own research, is that climate change can occur very, very rapidly, could warm very rapidly, could cool very rapidly. So I think probably something we really, really should consider is to develop really robust adaptation strategies to deal with whatever Mother Nature might throw at us, to be able to deal with droughts, for example. For example, the Pacific Decadal Oscillation, only discovered in 1996, okay? It's closely linked to something called the Palmer Drought Severity Index, is something which impacts agriculture in the West. You have drier intervals, you have wetter intervals. You have to be able to adapt our policies to be able to deal with these situations when they come about. So that's something I think we really, really need to think about, is to deal with whatever changes might be occurring, whether it's warming or cooling, because climate does change, it can claim to change rapidly, and we have to appreciate that based on what we know from the geologic record.
Are you done, Senator Banks?
Yeah.
Thank you very much. Those are 4 interesting bets. Senator Neufeld from
Thank
British
you.
Columbia.
Thank you, gentlemen, for being here. Very interesting discussion. I'm kind of on the same page as Senator Mazzacott. I mean, when we were in Alberta, we heard from some scientists, had all the correct documentation behind her name, that, wow, it's so simple, it's happening. and we go from one extreme to the other, for us anyhow, from one side to the other side. And I'm definitely not a scientist. I depend on people like yourself that have gone to university, have done the things that you've done in your lives to do whatever you're doing. And so I want to tell you that for me, I'm not sold either way. I'm still wondering. And I've been involved with it quite a bit over the last decade or so. So if you think about Fred and Martha, that's the people in their busy lives, they're likely not, in most cases, thinking about it too much because it is so controversial. I'd like to ask how many scientists, such as yourselves, would be on the same kind of, I don't know, wavelength as you are in your thought processes. I'm not disputing your thought processes. I'm just asking, is there a lot of them? Are they just quiet? Do they never say anything? And if they are quiet, why the heck are they? Because the other side of the fence is very loud. And I'm not talking about Al Gore, because Al Gore is just another politician to me that is traveling around the world and probably most of all kinds of vehicles that consume huge amounts of fossil fuels and telling everybody else they shouldn't use it. So I'm not talking about Al Gore. I'm talking about scientists. I'm talking about people like that have the training to talk as you folks are.
Senator,
So can I just, what I heard, I hope you'll forgive me, Senator, both Senators Mazzacott and Neufeld are basically saying, you know, we are hearing much more from the other side, the other point of view than the one you guys are expressing. And why is that? Is that not basically it, Richard?
Well,
yeah.
I think the question
You both
is,
asked that
yeah.
question. Yeah.
I can only answer from my experience. But first of all, once I read somewhere that when the bandwagon is rolling, one has only 2 options: to be part of the engine or part of the road. Okay, so bandwagon is rolling. I grew up in Czechoslovakia in a communist system, and I know there was Lysenkoism and things like that. You just had to go with the bandwagon. Now, this situation, I've been very senior and well-supported scientist, both in Europe and here. I have no complaints. But I believed in it, and I in fact started working on the whole issue because I wanted to find the so-called missing link for carbon dioxide because Canada would get the credits for it. And eventually I turned around after many years, several years, and the point is that all those things what I'm telling you about, the cosmogenic nuclides, the role of the sun, there was lots and lots of publications. You go into IPCC, and the whole issue is essentially dismissed in 2 sentences, and it doesn't exist. Now, what we are showing you are data, not models, data. So, are we having a science where good correlations mean nothing, and no correlation are a proof for CO2? We showed you the correlation. Those are known. Now, and these papers, including mine, were published in Nature. Not a word in this. In fact, there were even personal threats and attacks and defamation actions being organized against people who talk about sun. So it's changing now. Slowly it's changing. And science is not a democracy. Okay? So if the data do not fit what the models are saying, then it's not the data which have to be changed, it's the models.
I could add to that from the perspective that we see climate warming has become a very big industry, and not only in the political realm, but in the scientific realm. And a week ago, I was out in Calgary. I had a public debate with a person he is a research chair in climate change. His research money comes from the fact that we're warming up the planet catastrophically. And privately, we had a lot of discussion about this. And he said, what people say, would emphasize to me, what people say scientifically in private and in public are 2 different things. And he says, I agree with the science. And then in the debate, he agreed with many of my points. In fact, he agreed with all my points. But he would still come back and say, but we're putting CO2 in the air. It's a greenhouse gas. It must be having some effect. So what people say publicly and what scientists perhaps think can be 2 different things. And I think we have to be very careful in buying into the conclusions of scientists who are fully funded to a great extent, far more than the skeptical community, if I can say it, are funded. And so to a certain extent, they'll stick with their party line.
Okay. As far as warming up, I mean, where I come from, I live in northern British Columbia, so I've worked in the north a good part of my life in the oil and gas industry, and I've spent a lot of time outside. That's why I don't like the cold anymore. But I know where I live, and I mean, I'm not very old when you're talking about the world and all that, but where I live, it is warming up. To me, there's absolutely no doubt about it. I know it's much warmer, and I don't get near as much snow as what we used to. And people can't go to work in the bush and the soft ground until way later than they used to. So it's general that it's warming up. So I guess that's one thing that I kind of relate to. I can relate to that in my own lifetime. I've heard a lot of talk about the North from scientists, both those that are maybe thinking it's not warming up, and those that think it is. But I've never heard, and usually talking about the north and the glaciers and the very north, I've never heard many people talk about the South Pole. In fact, I don't think I heard anything, unless I missed it this morning, from you folks about the South Pole. What's happening in the South Pole as compared to the North Pole? Or why do we just talk about the North Pole? Help me a little bit with that one, please.
Firstly, we do not, nobody is arguing that there is no increase that there is warming trend. We all agree. That's not an issue. The question is really, what is the
cause?
The cause? If it would be warming wherever that energy is coming from. Okay? It doesn't. Secondly, concerning South Pole, what you hear in the media and everywhere is the so-called it's the so-called peninsula, which is a very small portion of Antarctic, about 3% or something like that. That's where it's warming, yes. But the 97 or 90 whatever percent of Antarctica, if anything, the ice cover there is either stable or growing.
Okay.
We could also comment about the Arctic, because I work in the Arctic. In fact, one of the major research areas that I'm involved in is the impact of warming up there. And we've seen 100 years of warming in this over the past century, and so permafrost temperatures are higher, and we have triggering events, and we study these mud slumps and thaw slumps. Very impressive features, and we see this evidence of warming up there. So we have to put that in perspective with 100 years of warming, most of which even the IPCC agrees to have been natural warming, and this is warmed up in the Arctic. And recent research shows that the current warming trends observed in the Arctic aren't due to greenhouse gases and the greenhouse effect. It's due to a change in air and ocean circulations, the patterns that Tim was talking about, the Pacific Decadal Oscillation, the North Atlantic, and so these are mechanisms of warming in the Arctic that aren't predicted by the global warming models. They're quite different from that. So yes, we have this warming, but it's unrelated to greenhouse gases.
Okay, thank you. Just one.
Yeah, okay, we're running out of time, but you have one little shorty?
Just one little thing, and it's more of a statement, Chairman. I read recently that it takes numbers of billions of light years for light to traverse from one side of the Milky Way to the other. And I think to myself, my goodness, here we are just a speck on the Earth, and we think we can do something to actually change what's happening in the whole unbelievable universe that we have out there. That's just a statement.
Thank you. Senator Wallace.
Thank you, Chair. Thank you, gentlemen. The discussion ultimately comes down to solutions, and that's where the disagreements have been occurring. What solutions should be implemented? But I guess the solutions will depend on what's the problem. In fact, is there a climate change problem? And when I listen to what each of you have said, evidence is presented on temperature changes over thousands of years, and we see patterns of warming and cooling, and I guess the Earth is always evolving. It's never static, and so that continues today. So the question I would have before we talk about solutions, do each of you believe there is a climate change problem that we should even be attempting to address, or is it one that's beyond the ability of humans to affect in any event?
If I could just jump in for a second. For many years, I've taught a climate change course at Carleton University, which, much to my chagrin, grew up to about 800 students before I escaped from it for a little while. But one of the first things I would try to get across to the students is the only constant about climate is change. Okay, so that's something we've talked about here already today. Climate changes perpetually. And as all of our research has shown, sometimes the changes can be quite dramatic. So It's not an issue. There's not a climate change issue. There's always a drought going on somewhere in the world. The big, or there's warming, or something's happening someplace. The big things that we have to really think about are how can we adapt to this? How can we get resources from one part of the country or one part of the world to the place that's having a problem? So I think really the thing that we should be really thinking about is how are we going to adapt to the climate changes that we know are going to occur and that can occur at very rapid timescales at times. So that's my perspective.
So your conclusion would be we cannot, as humans, we cannot alter that change in climate. All we can do is adapt to it, and that's where we should focus our resources.
Yeah.
That would be your opinion.
My opinion, and for the other issues about what people are always talking about pollution and so on, well, I deal with it, okay? So to develop cleaner technologies to deal with the real issues, the NOxes and the SOxes that basically are creating air pollution. That's where we should be putting our money in. Because, we live in a great city here in Ottawa, for example. It's a wonderful, clean place. I've visited China and Jakarta and these places. I would not want to live there, no way, because the air quality is so terrible. So we want to deal with these real air pollution issues. Climate change is not something that we're going to change. I read about this magical 2 degrees Celsius all the time that we can't get over. What's the magical of 2 degrees Celsius? There's much, much more variability even in the last 10,000 years than 2 degrees Celsius. What we have to do is adapt ourselves to whatever's going to happen.
Thank you. I personally, I believe there are both. There is sun and there is some contribution from CO2. Okay, it is there, but it's not the way 90% is human and CO2 and the sun is practically non-existent. It's, if anything, it's the other way around. Okay, so if there is any impact, well, and there is a pollution. You can also argue, okay, when we burn, we pollute. So it can be used as a measure of activity somehow to calibrate our pollution, okay? But not claiming 2 degrees or 4 degrees or 6 degrees because the models are simply not there.
And your conclusion was the major influencing factors
It's
climate
always-
change are water vapor and what you
It's-
referred to as electromagnetic envelopes around
no,
the sun and the Earth?
This is one of the ways. The major problem is the clouds. Nobody knows how to make clouds. Okay? You have to see them. So you probably heard about the big experiment which was just happened in Geneva in the so-called cloud experiment, okay? Which confirmed what the others were saying, like Svensmark and myself for years now, that yes, you generate small particles which can serve as nuclides for those cloud, and there were data showing that there are correlations. But the problem which is there is now how to make those very tiny particles into big aerosols, which can be used for formation of droplets. So they say, oh, because of that it has no meaning. These are already, this all fits into the situation, into the model of sun. But that problem, how to make clouds, is exactly the same problem which is in CO2. They don't know how to make clouds. So why in one case it dismisses the entire theory, and in the other case it's no problem? Okay? They have exactly the same problem. They are putting the clouds. I told you that the change between cloudy and cloudless sky is 30 watts. Okay? We are arguing about 1.6 watts. Okay? So you just know it yourself. When sun shines, it's warm. When it's cloudy, it's cold. Okay, that's how it is. And so, if you can make the clouds, and neither theory knows how to do it, and the clouds are being put into the model as plus 0.6 or something like that watts. Yet the variation is 30 watts. How can you do that? Those 1.6 watts is a number which is taken from very huge numbers, positive and negative ones, which by themselves have bigger error than 1.6, or at least the same big. Okay, so this is the whole issue. And there is lots of experiments now going on in that way. So why one theory is dismissed and the other is okay?
We're running out of time, but do you have more questions?
No, that's fine. I know
Okay.
Senator Mitchell had
Well, I want to
some
save time for Senator Mitchell. I've got still Patterson and Peterson, so Senator Patterson.
I'll try to be very quick, Mr. Chair. Thank you very much. I'd like to ask Professor McKitrick a question from the economic point of view. So we've heard that carbon is a very small factor in climate change, that the real influence is the sun and water vapor, and you talked about the danger of us muddling for another 20 years. I'd like to ask you specifically, the Government of Canada has committed to reducing Canada's total greenhouse gas emissions by 17% from 2005 levels by 2020 through a sector-by-sector approach. And I think what that is directed at is carbon dioxide. Would you say that in light of what we've heard today, which I found, quote, very compelling, would you say that this approach is misplaced and that it would be another way of muddling for another 20 years? Thank you.
Yeah, actually, even if you took the IPCC view on the effect of greenhouse gases, what the Government of Canada has proposed would have such a small effect, and even if our major trading partners agreed to the same target, this is the point that I made about the Kyoto Protocol earlier. We had enormous difficulties trying to reach that target, and yet the same models that said you've got a problem said you'd need something 30 times larger than Kyoto to even start showing up in the numbers in terms of actually arresting the process. There's a scale problem here. So if they're going to go, whether it's sector by sector or a carbon tax or anything like that, you're still entitled to ask, what exactly does that buy us in terms of the underlying issue? And I think if you ask that question, they would come back and say, well, it actually wouldn't change the global warming story at all, almost regardless of whose view on the science you take. And so that being the case, I would say the current technology makes it very difficult to know what to do with CO2. It's not like sulfur where you can capture it and it becomes a solid, you can dispose of it. You capture CO2, it's still a gas, you have to put it somewhere. And the scrubbers just aren't very efficient compared to particulates and sulfur. So under our current technology, I have considerable doubts they can even achieve a 17% reduction without ending up having to impose some pretty significant costs on major sectors. And if you ask what does that buy us, on anyone's view of the underlying science, it doesn't really buy you anything. So I would like to see that target debated much more robustly than it has been.
And the effort you mentioned on particulates and sulfur dioxide, which you said seemed to have been effective on the Canada's part, from your point of view as an economist, do those efforts produce economic benefits?
Back in the early 1970s, Toronto particulate levels were over 100 micrograms per cubic meter. Today, they're about 30 micrograms on a bad day. Sulfur dioxide would have been about 140 parts per billion. Almost every city in Ontario now, it's between 1 and 5 parts per billion. It's not even measured in most places anymore because it's gone. In those cases, you had fairly inexpensive technologies that just pulled the stuff out of the smokestacks, and catalytic converters on automobiles get rid of about 97% of what used to be emitted in the 1960s from automobiles. So there you have low-cost technologies that actually give you a huge benefit. We're dealing with the opposite with CO2. You've got very high-cost options that give you very little benefit. And again, on anyone's view of the science, on the economic side, the numbers keep coming out really unfavorably towards these Kyoto-type or more recent efforts to impose targets. The numbers just don't add up for them.
Thank you, Mr. Chair.
Senator Peterson.
Thank you very much, Chair, and thank you, gentlemen, for your presentation. We keep reading that we're moving rather quickly towards a break point, at which time the situation will be irreversible. I'd like your comment on that, because if we're still studying issues at that time, be a little too late to do any adaptation.
I guess I could start off commenting that these breakpoints are based on speculated feedbacks that the Earth is going to behave in a predictable and measurable way. And I think that what we've shown today, I hope, is that the Earth is very unpredictable and it has a lot of mechanisms in the climate system. The climate system is incredibly complicated. It's almost chaotic, although we find that there are cycles, there are events, and over geological time and over recent decades, these can then be taken and projected into the future with some relative certainty. And I think what Tim has been talking about with the ice roads work and the Pacific Decadal Oscillation, things like that, shows that there is some prediction that can be made. But catastrophic. We hear these words, we hear these alarmist calls that the only habitable place on Earth in 100 years will be Antarctica. Came from the scientific advisor to the British government. And these are nothing more than alarmist comments. And so the idea of tipping points and that we're going to go into irreversible climate feedback and a warming planet that will be uninhabitable is really wild speculation on what scientists might be saying, and certainly the politicians and advocates who pick up on these comments, and it's absolutely ludicrous. And we don't see this in the geological record. We see a balanced system that restores its equilibrium after a period of 100 years or 20 years, and I must point out that much of this science has been documented in a very good publication, Climate Change Reconsidered, by two groups, CO2 Science and the Science and Environmental Policy Project, which I believe is available to you all. I have a hard copy here, which is to be left, but the science behind this that we're trying to present today is well documented here in the literature.
Good?
Yeah.
All right, Senator Grant Mitchell, the Deputy Chair.
Thank you, Chair. I want to begin by saying that, I don't doubt the sincerity of our witnesses. I think that sincerity is all that much more underlined by virtue of the fact that they sustain their position and they sustain their work, and in the face of literally thousands upon thousands of scientists and economists who are independent, who are spread out throughout academic institutions and other institutions across the world, and who answer and overwhelm the points that have been made here with devastating consensus and with devastating frequency. So I want to say that I don't doubt your sincerity. It isn't just the IPCC, and that's a straw man that's been raised here. It is every scientist that takes the position against which these gentlemen are opposed are not just IPCC scientists. This is independent scientists, literally, all over the world. And so in a way, to believe these arguments is to believe some kind of strange conspiracy theory, that all of these independent scientists, somehow we have to question their integrity, their motivation, assume an ability to conspire across the world in a magnitude that's almost incomprehensible. Their scientific acumen has to be questioned over and over again. And I think, when I think of a conspiracy theory, one statement that was made today that really underlines that thinking in these presentations is the one that said somehow that the Harper government is clamping down on scientists to enforce elite climate change consensus. The Harper government, of all people, would enforce their scientists to support the idea that climate change is occurring and that people are creating it. Of course, they'd be the last government that would force their scientists to do that. And in fact, if you read the documents that come out of the Environment Department, somehow they squeak out. They all underline the urgency of climate change and that we're occurring. I'm left with this impression of the woman who once said, while watching her young son march in the military parade, "Everybody's out of step but my Johnny." And of course, everybody's out of step. The thousands upon thousands upon thousands, the 99% of scientists are out of step, except So the difficulty, of course, in this, and I appreciate your presentation, is that point by point by point by point, there's devastating science that confronts and overwhelms what you're saying, and maybe we have to go in that and bring in other testimony but I think we probably don't, because I think in the end this will settle this relatively weak. I'm going to say that David Keith, I'm just going to say, that David Keith, just to get this on the record, because some of our colleagues weren't here when David Keith, who's a renowned leader in this area, is a physicist and very, very hugely well respected. He said, one last thing that made me smile in response to testimony like what we've heard here is that this idea of testimony that we do not know how much impact humans are having on CO2. He said, come on. We have multiple, completely independent, overlapping ways to measure that. We have it nailed. And claiming that it is not true, to me, is like it speaks to a problem we have in our society of a kind of fundamental lack of trust in institutions of science and rationality. It is the same kind of attitude, I'm going to underline this, that we have saying that vaccines are dangerous so we won't vaccinate our kids, or that cell phones cause cancer, or that evolution is not true. I'll close by saying that Professor Veizer said one. He said very, very clearly later in the questioning, no one disagrees with a warming trend, and went on to say, but of course, and this is the essence of your testimony, even if there is one, it's not being caused by humans. And what I will close with, and we're running out of time, so I won't ask the question, I would just close by saying, if humans aren't causing this, then you have to be, and we all have to be, very, very afraid, because if we're not causing it, we can't fix it. And there is no evidence or no ultimate suggestion in any kind of science that I've ever seen, if it's happening spontaneously, it's going to stop at some level, that's some manageable level that isn't going to be too hot, way, way too hot, or way, way too cold. So I'll just say, great. I'm glad we had them here. I'm glad we got the other side, and we'll deal with that as we progress with our study and writing our report.
Well, thank you, Professor Mitchell. Colleagues, is there any further, Senator Lang?
Yeah, I'd just like to make a point here. I appreciate the fact that Senator Mitchell and I have a difference of viewpoint on a number of these issues, but I do want to say to you gentlemen that I don't see what's being presented as a, quote, conspiracy theory, because it seems to be out of step with what the general public is being told across the world. I want to say that I really appreciate the fact that you bring scientific, what I saw was scientific background, scientific actual facts to the table to say this is what's happened in the past. And one of the areas that does bother me as a Canadian is the political spin that's put on that climate change has not occurred since, or has only occurred because of CO2 emissions. And I think the reality of it is today, not like any other time, climate change is taking place every day, not necessarily because of man. So I just want to say that I would like to leave this today and a challenge to you gentlemen and others that have another point of view, that you do everything you can to get out to have that public debate, because I feel that it's been muffled. I feel that governments have intentionally and indirectly have put you in a situation where, yes, some people have seen it as a conspiracy theory. And I think that there's a place for that debate, and I think it should take place, especially if we're going to be looking, as Mr. Patterson's indicated, his research has indicated that we may well be looking at a cooling period for quite some time. And if that's the case, then we really better have a look at what we're doing. Thank you.
Can we have a summary?
Reminds me of my days pleading cases in court. The closing arguments have been made by opposing counsel, and they've been duly taken into consideration by the lordship. But there are two supplementaries. Senator Rain, you have the word, and Senator Brown, and then we'll suspend.
I would just...
Unless our witnesses want to have a wrap-up.
I would defer a question I would like to hear from our witnesses.
No, but you can. You've been so quiet.
I don't have any questions. I do want to hear their
yeah, you will. Yeah.
I'd just like one comment. Within the earth science community that we represent, our viewpoint is not terribly out of step with what we find there. If Senator Mitchell were to come out to one of these large-scale meetings which we attend, where there'll be 1,000 people presenting, our point of view is presented by large numbers of researchers out there. There are issues sometimes in the way that sometimes the publications are able to get into. For example, Nature Geoscience presented a paper a few weeks ago projecting a 17% reduction in the ice road capacity by 2050. If you looked at the underlying data that was based on that, it was based on 5 years of data that research was based on, but somehow was able to be published in one of the premier journals in the world. Here we are coming forward now with data we'll be presenting based on 5,000 years of annually data rather than 5 years of data. So there's issues sometimes of availability of the data or being able to get out there. For example, Professor McKitrick pointed out the issues that are rampant within the IPCC, which actually does suppress the sorts of research. But if you did actually look at the overarching literature that's out there, which is very, very large, you'll find that our perspective is not terribly out of sync. It gets reported differently. I think that's the main point of view here.
Patrick, yeah.
Just 2 points. First of all, Senator Mitchell, I didn't say the Harper government, as the Harper government, suppresses their scientists. What I said was government scientists don't have as much freedom to speak their own mind as people in academia do. And I think that that's true regardless of which government is in power. The second point is...
support your position.
I've been involved in, last summer I was involved in a debate at the American Statistical Association where they put a panel together to look at applications of statistical analysis on these climate issues. And the same basic questions keep coming up. The difference between what the models project and what the data show is there. It's in the data. It's understood to be in the data. Now, if you hear from someone like David Keith, who I know and is well respected in his field, rather than just taking at face value the idea that he speaks for a very large group or consensus, ask him, how do you explain these discrepancies? I mean, maybe he has an answer that hasn't occurred to other people, but the discrepancies are out there, and I think they need to be dealt with.
Thank you, sir. Now, are you, what was it? McGrath, what was the name of the senator from, go ahead.
I want to say that the real deniers in this whole thing are the people who started out with Al Gore's movie and said that global warming was the problem of the world, and in less than 2 years it became climate change. And it wasn't climate change in the beginning, it was about global warming. I also had a thing from the NASA people that said so far it's warmed 0.4 tenths of a Fahrenheit degree. Thank you.
Senator Mitchell, is it possible to say something here which won't be recorded?
Yeah, you're free to have a talk with Senator Mitchell. But we're on the record now, and is there something that you don't feel comfortable having public?
Well, this is
Velcro lips is what I was taught.
The issue of that there is lots of people simply say, yes, it is like that. It is CO2. Okay, I'm going to ask you. It's a bit pushed, but how many of you do realize that there is no CO2 in the climate models which do all those predictions? Okay. There is prescribed CO2. It is called prescribed CO2. That's energy. Just because it's called prescribed CO2, it's not CO2. Okay?
Listen, I would like, on behalf of the Senate, on behalf of this committee on energy, the environment, and natural resources, to thank you all very, very much. This hearing was put together in a fairly short time. You've given very thoughtful presentations. You've had a very, I thought, balanced reaction to our diverse views, and all four of you have helped greatly, and you've made some of us more aware than others, about what you think, and it's helpful. And we may well need to call upon you again, Senator Mitchell and I and Senator Neufeld, or the steering committee, and we'll see. But this basically, the study we're doing is really about the energy system, and so the sun is a big player, right? But anyway, thank you so much. I want to thank you very, very much. Colleagues, I'm going to suspend, and then I'll just take 2 minutes to wrap up. Merci beaucoup. Thank you very much, gentlemen.